Okay. Welcome again. This period, I want to use this particular medium, this period, to explain how gauge, single gauge works, and how the symbols, all these symbols, what it means, how to interpret them, how they actually, how they actually help, what is their function, why are they actually on this gauge, understand? So I want to use this medium to explain it in totality, to tell you how it actually work, the function of each of these part, and if I can even unveil this plastic bag to show you what you need to know about this single gauge manifold. And okay, if you closely observe the gauge, I don't know if you can read, if you can see how many, if you can see how many lines or how many curves you have here. You have curve number one, which is the bigger black curve. You have a bigger black curve there. Also you have curve number two, which is the red curve, and curve number three. All these curve you are seeing here, they actually mean something. They have what it means, understand? If at the course of this, if at the course of this life you don't understand anything, type it on your comment box, chat me, tell me that you don't understand this part, I should explain better, and I will do just that, understand? Now this bigger curve, okay, let me, that's why I actually brought this paper for us to see how the whole thing goes here. This bigger curve, this is the bigger curve. I'm only just giving a sketch here. This bigger curve has two parts on it. I don't know if you can see it from the gauge. This bigger curve has two parts on it. There's a calibration up here. There's a calibration up, and also there is a calibration down. If you can see it, you observe what I'm talking about. There is a calibration down. The calibration ups up here actually tell the number of the kg you're actually operating with, the weight of the gas you're actually operating with. But with this single gauge manifold, this kg doesn't actually have, it doesn't actually work here, understand? This bigger, the outer calibration here, which is the outer numbering here, it doesn't actually work on this single gauge manifold. Now what you see working on this single gauge manifold mostly is the inner calibration. This inner calibration, it starts from 0, move up to 20, move up to 40, move up to 60. Now this is the PSI, reading. This is the PSI reading, depending on the kind of refrigerant you're actually charging. Depending on the kind of refrigerant you are charging. If you are charging okay, let me just use for example R22 refrigerant. R22 refrigerant, as we all know, has a PSI of 660 PSI. So once you charge your R22, it will start from this 0 calibration. The needle will be pointing at this zero calibration, what you've just noticed here now. That is what you will have, that's what you will see on while charging your 22 refrigerants, or let me just say in general, it starts from 0 psi. Understand? Once you are charging it gradually, you are adding the refrigerants into the system. It's actually moving up to 20, moving up to 40, moving up to 60 psi. Now this 60 psi you see here has actually ranged out for R22 refrigerant. And also you may be thinking, what are the function of most of the parts here on this single gauge? Can you see how the single gauge is? Let me try to touch the zoom for you. Okay, I believe that's better now. Can you see how the gauge is? This is a single gauge manifold. In this single gauge manifold, we have two knobs here. One is an inlet and the other is an outlet. Understand why this one controls the pressure, controls what you're actually giving to the refrigerator or the air condition at a particular time. This is the inlet valve. Any single gauge you pick up, understand, it will look like this. It will look like this, except the digital ones, understand. But in this analog single gauge, this is how it looks like. So many people doesn't know how to operate this and how to use this to work. It is a very easy pace for you to know that, okay, this is how single gauge work. This, when you hold it like this part is the inlet. This is where gas passes from into the system, understand. And this is where gas leaves from to the air condition or to the refrigerator you're actually working with. So I have two charging hoses here. I have two charging hoses here. I love using this particular charging hose for the inlet so that I will not mistaken anything, or I will not fall victim of any kind of circumstance while I'm working. And my color coding have to be very, very obvious. This is where the inlet comes in, and this is where the outgoing gas comes in from. Can you get it? This is where the outgoing gas comes in from. And this is where I can control my refrigerant level. Before I actually go into this to explain more about this, I need to just tell you how all these things work. This is where I control my refrigerant level. You get it? And secondly, I need to show you this because this is a total breakdown of single gauge manifold. I wouldn't want to withhold any knowledge from you. This is just a lid. This is just, should I say, like a pouch that protects it when it falls down or when it goes to the ground. It doesn't slam itself and open up, understand? It doesn't slam itself and open up. It protects the system from damage when it falls on the ground, understand? So that is the function of this particular lid cover. Now let me unveil what you have behind this lid cover here. Let me unveil what we have here. Can you see? Behind it you have two knob. What does this two knob do? This two knob is what is holding the this inner calibration setting. This inner calibration, this two knob is what is holding it on place, and also holding this thing firm to this head, understand? Also you have this cover. This cover just shields it. If you see now, you can easily touch what is inside, and if you continue touching what is inside like this, you may end up scattering, or should I say cleaning off what is written here. So you must give notice to read for you not to damage it up. And also, if you look down here, you see a needle like stuff. Can you see it? A needle like stuff is just here like this. Very good. This set as a stopper, understand, as a stopper. If this calibration rotates itself to a particular point where it cannot rotate itself again, it stops here, understand, it stops here, which is the main point where it is being designed for it to stop, which means no calibration should exceed this point, this particular stopper you're seeing here. So that's how it is. And another thing I need to explain again is there's what we call zero error. Understand? There's what we call zero error on scale. Let me explain that to you. Get that back from me. Hello? Hello? Get that back from me. Okay, I'm here already. So there's what we call zero error. Let me use this point to explain to you what we mean by zero error. This is used to correct your zero error, so you don't have error, or you don't go wrong when you are charging your refrigerant. This is a screwdriver. I will use my screwdriver to correct my zero error. Now this point is used to correct zero error. Notice, just use your eyes and observe what's going on here. Observe what's going on. Can you see? Can you see that? So we use this knob to correct zero error. So if I should tighten it again, it comes back to its initial point. So if there's how you can buy a new gauge and it doesn't start from this 0 point. It doesn't start from this point, it's 0. You get it? So as it doesn't start from this point, it's 0. You can now use this knob to adjust where you actually want it to start from. If you want it to start from here, you can always still start. So I would want to make you understand this, okay? So I've been able to open like this because we will be working with this. Seriously, we'll be working with this. If you don't understand anything at the course of this life, please use your chat box to tell me or to communicate to me that, okay, at this point you don't understand what I'm talking about. I can re-explain it again, and I can retouch all the angles again. All right, let's keep going. This is a single scale. As I say, this is a single gauge. This is a single gauge. If you observe on the single gauge, you have curve 1, you have curve 2, and you also have curve, and also closely again. Fortunate because understand their reading in different refrigerants involved here. We have R502 here. We have R502. We also have R12 here, and we also have R22 here. Understand? We also have R22 here. Now, I want to take my time to explain how this gauge works and how to actually use it. So this is a good part for you to be able to understand how single gauge like this works. So very good. We are so fortunate that if there are other type of scales in the market, but we are so fortunate that we have this handy. Understand? We are so fortunate that we have this handy. This part of the scale written on green, this part of the scale written on green is used for properly vacuumed, because if your is vacuum, this needle you are seeing pointing at will shift backward like this. Get my point? No air, no moisture, nothing is present in your system. You have your system complete. So that is just it. And shall we still proceed? If you lack anything you understand on this life, please do well to use your chat, ask question. I'm here to give you answers for it. Okay, let's continue. This first calibration up here, the calibration up here entails the kg, which is the kilograms of refrigerant you are using at a particular time. Entails the kilogram of refrigerant used at a particular time. But the psi, the temperature reading for both 502 R502 and R22 here. So PSI, R410 refrigerant is between PSI is between 140 to 120 to 140 PSI. So if you are charging R410 refrigerant, this scale goes up, or this needle goes up to 140 PSI. You get, if it reaches 140 PSI, or let me just say it stops at 130 PSI. They really stop at 130 PSI. Now, how do you know that you are actually on the right track? You know, the heat that comes out from the out that you feel out from the outdoor is due to the refrigerant's boiling point. You get me right? Now, this is the scale. This is the point you can get it noticed. The degree boiling point of a particular refrigerant. Now let's talk about this now. If you are dealing with, why I had to use R410, or why I had to leave R410, is that its degree boiling point is not here. Understand? Now let's use R22 for example. Let's use R22 for example. This if you charge R22 from scale from 0 degree, or from 0 psi up to 60 psi, as R22 is always 60 psi, you charge it from 0 psi to 60 psi. This is how to notice the boiling point of R32. If you observe here, you have the inner calibration here is for R32, while the outer calibration is for R12. So if you charge it to like 60 psi, the inner calibration for R22 is about 5 degrees Celsius, 5 to 10 degrees Celsius. You get it right? 5 to 10 degrees Celsius. That is the boiling point of R22 refrigerant. So that's how it is. Now, what do I need to explain more again is about different gases, how to charge them. It's about different gases and how to charge them. Okay. Okay. I've just closed up the lids to cover up the pouch. Okay. This is being set up. Let's consider for okay, let's start with, I want to talk about refrigerants that has to do with air condition. You know, air condition mostly use in air condition, which is AC. We mostly use R32 refrigerants. We use R410 refrigerants. We also use R22 refrigerants. This is air condition. I mean normal air condition, not a car air condition. I know car air conditions use different refrigerants, like the 134, like the 600A. Understand? So this is just for a normal split refrigerant, normal split air condition. Normal split air condition, we use R32 and R410 with R22 refrigerant. Now the calibration for, okay, let me say how to read scale for okay, let me just say how to read PSI for R22 refrigerant. You get it? How to read the PSI for R22 refrigerant. Okay, R22 refrigerant. Okay, this, we are now about to talk about R22 refrigerants. We are using the outer scale when it comes to gauging an air condition. This is the outer scale with the inner calibration. In some scales, you may experience that they have this psi is being rated in the, or is being written in the outer part of the scale, but in this my type of scale here, we have it in the inner part of the scale. So let's say this is psi, this is 0, this is 20, this is 40, this is 60, this is 80, this is 100, this is 120, this is 140, here is 160, here is 180, here is 200, 220, and 240 psi. Now we are dealing with R22 here. As we are dealing with R22 refrigerants here, this has to do with R22 R20 is equal to 60 to 70 psi. So this psi means British pound units. I believe you should know that before now. PSI means British pound units. So we are now dealing with R22 scaling here. When your set up your gauge on your air conditioner, okay, we are talking about air condition. When you set up your gauge, if you don't have any form of refrigerant on the system, or no refrigerants on the system already, you need to see on the scale is what you notice on the scale is that 0 psi. It will start from 0 psi. That is what you notice when charging a fresh system that doesn't have a refrigerant on it. You notice it starts from 0 psi. Once you start adding refrigerant on the system, once you start adding up refrigerant, it increases up to 40. You keep adding refrigerant, it increases to 60. If you want to stop at 60, it's not bad. If you can extend to 70 psi, that is also still good. That is also still better. So this is what you have for R22 refrigerant. Okay. Now the bottom part is the inner calibration for us to know the temperature, the outdoor boiling point, like the refrigerant temperature in the system. You have another inner ring here. Then this ring entails that in R22 refrigerants, it has a boiling point of about 10 degrees Celsius. 10 degrees Celsius, which is here, you have it at 10 degrees Celsius. This really means that that heat that you always observe behind your outdoor system or in front of your outdoor system, that heat that comes out from your outdoor system, understand, is the boiling point of the gas, is the boiling point of that refrigerant. So you see that heat coming out as per 10 degrees Celsius. That is what you observe from R22 refrigerant. If you don't get anything clear here, do well to ask question. Understand? Ask question. Use your chats, comments, talk what you need to understand. Then I will take my time to explain it out to you. That is just it. Now we are moving to R410 refrigerant. This how to read PSI on R410 refrigerant. All right. In R410 refrigerants, you still have the same ring because this scale is actually a universal scale. You still have the same ring. If you have the one with inner calibration, this is what you will notice. You will see a calibration like this on your scale. You will see a calibration like this on your scale. You try to understand what it means. This is at point 0. We move to 20. We move to 40. This 2040 I'm talking about is the PSI of the system. We move to 40, we move to 60, we increase to 80. It's in 20. It's calibrated in 20 space, in 20 PSI spacing. This is 100, this is 120, this is 140, this is 160, here is 180, here is 200, here is 220, and here is 240. Okay, since we are dealing with R410 refrigerants, we all know that R410 refrigerants has a PSI between 120 to 140 PSI. Has a PSI ranging between 120 to 140 PSI. All right. If you are scaling R410 refrigerant, if you set up your scale on the R410 system and it doesn't have any kind of refrigerant on it, you see that it will fall down to 0.0, which is the 0 PSI. This is the 0 PSI. That is it, which is the 0 PSI. If you have refrigerant on it already, probably the refrigerant may not be enough for the system. That is one of the functions of using gauge while working. If you have a refrigerant on the system already, the gauge will tell you how much refrigerant you have on it already, how much refrigerant you need to add to the system, and how much refrigerant needs to saturate up that air condition. Understand? That is why you need a gauge while working. I always advise most technicians that when they are working with system like air condition or like refrigerator, they should try their very best to use gauge while working, because it helps them to know what is the status of a particular system, why a system is not cooling, why it's not working, or why it's not efficient. Understand? Why that system is not efficient. This helps them to understand that. If you also have a leakage on the system, if you are observing any kind of leakage on the system, gauge also help you to know if your thought is right or is wrong. I don't know if you get my point. Gauge also help you to know if your thought is right or is wrong about having a leakage on a particular system. So that's how it is. How do you know that you have a leakage on your system? Through your gauge. Now let me explain that part. If you have a refrigerant already on the system, probably like we are talking about R410 refrigerants now, and you have a refrigerant on the system, probably as you set up your gauge, you see that the refrigerant is at 60 psi instead of 120 or 140 psi. You have if it's reading at 60 psi, you allow that gauge to be on the system for about 20 to 30 minutes. 20 to 30 minutes will help you to notice if there is actually a leakage on that system. This is why the AC is still running. This is why the AC is still working. I don't know if you get the point. Either when the AC is still working or when the AC is not working. Once you just set up your gauge, you know what you are doing. If you set up your gauge, if it gives you 60 psi, You allow it there for like 20 to 30 minutes. If there is a leakage on the system, if you come back, you will notice that there will be a psi drop either by 1 unit, 2 units, 3 units, or 4, depending on what you notice on it. Understand? Depending on what you actually notice on the system. So that is just it. Like for what you have here now, if you 60, if you have a gauge reading at 60 psi, and you notice you feel there is a leakage on the system, you left it there for like 20 to 30 minutes. Before you come back to observe your system, you will see that there will be a psi drop to the left. It will be either 1 unit or 2 units or 3 units. If it's a leakage that is very, very obvious, you see that it will drop a hole down to this point or even come down a little bit again for you to notice, okay, there is actually a leakage on this system. That is how we notice it, and that is how we know that there is a leakage on the system using a gauge. So let's continue with what we were saying about R410 refrigerant. If you are charging R410 refrigerant from point 0, this is from point 0 at 0 psi. This is from point 0 at 0 psi. You have this, understand? You have this. When you keep charging R410 refrigerant from point 0, you increase it to 20, you increase it to 40, you increase it to 60, you increase it to 80. At this 80, that is where you start observing expansion. When I mean expansion, you notice that the discharge line on the air condition will start freezing. I don't know if you get my point. The discharge line of that air condition will start freezing, will start forming icing. Then with that point, that's where you know that, okay, that's where your expansion starts. But you don't stop charging up the refrigerant, you still keep going. You increase it up to 100, you increase it up to 120. If you can still increase it up to 140. That 140 psi, you set it up, that is where you are good to go. Understand? At this point now, you have actually free up the system, you allow it to work, and it's running for as much as it can run. I don't know if you get, for as much as it can run, as far as you don't have any leakage on the system, your air condition is to run for as long as it's good. Understand? And at 140 psi is the ideal psi, for R410 or R410 or R32 refrigerants. Okay, this explanation was for R410. Now let's move forward to R32 refrigerant. Okay, let's move forward to R32 refrigerant. This is how to read PSI on R32 refrigerants. Yeah. You have to draw the scale up again. And we also have to calibrate it. To be sure of what we are doing. We have to be very, very sure. Now this time around, I want to calibrate it on a, should I say, 15 spacing, on a 15 spacing interval. This is 0.0, this is 0.15, this is 0.30. Why I have to do this is that different gauges have their own calibration differences. Understand? Different gauges have their own calibration differences. So that's why I have to start from 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, and 180. Yeah, that is an ideal calibration. That is an ideal calibration. That's how it actually goes. We can also say that as it stands like this, since we are dealing with R32 refrigerants, this point with this is the PSI reading, this point is the 0 point, is the 0 PSI, is the 0 PSI, and if we are dealing with R32 refrigerants, R32 refrigerant has a PSI of, R32 has a PSI of 110 to 120 PSI. 110 to 120 PSI. So note that as we go. 110 to 120 PSI. When you are starting from point 0 to fill an air condition that has no refrigerant at all, you will notice that your needle will start at point 0, which is point 0 here. Your needle will start at point 0. But if you have a refrigerant on the system already, depending on the quantity of refrigerants you have on the system, it may fall up to 20 psi, it may fall up to 40 psi, it may fall up to 60 psi, it may fall up to 80 psi, depending on the quantity of refrigerants you have on the system. If you don't understand what I'm explaining, or there's something you miss, you tell me, you write it on your chat there, ask a question, and I'm available to give an answer to that. So we are dealing with R32 refrigerants at point 0. When I mean at point 0, I mean that there is no refrigerant at all on the system. You are the one to fill up the system to saturation. So at point 0, you start from 0 psi, you increase it up to 15 psi, you increase up to 30 psi, 45 psi, 60 psi, 75 psi, 90 psi. You move up to 105 psi, 120 psi, and you can remember that R32 is between 110 to 120 psi. 110 to 120, so you don't allow it to exceed 120 psi. That's where you lock it up for R32. That's where you lock it up. Understand? Once you lock it up at that point, you've actually achieved what you want on the system. Now, another part of this scale I need to explain further again is that if you notice this scale has, if you notice the scale has this green reading. The green part of this scale, this part is the green part of the scale. We use the green part of the scale for vacuuming the system. So if you want to vacuum your system, vacuuming your refrigerator or your air conditioner system. Very good. You see this part of the scale. I need to draw out a scale again, which is being calibrated to a certain number, and it has where it is actually going to. The numbers here I've actually explained it. The number in between here, which is the two red lines here, I've also explained it. And now what I need to explain is this particular line here that has this, and this. You get it? This is for vacuuming. This at 0.0, and here you have 30 pounds. Okay, you have here at 30, and this part here is let me identify it as this. So this is how it is. This part of the scale you are seeing here, this part of the scale here is for vacuum. So if you have this part of the scale, and if you have this part of the scale on your own scale and you don't know what it means, that part of the scale is for vacuuming. That part of the scale is for vacuum pumping. That is just it. So with this now, I've been able to explain the entire function of a gauge, a single gauge, how you can use it, how it works, and also how it helps our daily installations, our daily work system, and how it helps our daily work system. So that is how it is. If you understand this and you understand it well, you will see that, or you will notice that installation of this kind can never be a problem. You get? Installation of these sorts can never be a problem. So that is just it. This is a gasket. I have to open this up so that you see how it is. This is a gasket. Let me unlock this. All right. Okay. We got this removed. It's just a single knob that helps control the pump system. Okay. So this is how it looks. It helps to control pressure. This helps to control pressure. Can you see it? All right. I have to send it all the way in again. Okay. So I've just taken my time to explain how this thing works, and expected to see on the field. Understand? What you are expected to see on the field, because this is best explained on the field and not just vocally. I can also do well by showing you what we are talking about here. Okay. um I believe our next video will be on troubleshooting. Will be on troubleshooting and air condition. But let me just give you an intro of how it will look like. Let me give you an intro of how it will look like. This is okay, let me say, where do I start from? Okay, let me say outdoor system. Okay, we got this. Step number 1, voltage. That is one of the factors that could stop an AC outdoor system not to turn on. One is the voltage. So how does voltage actually affect an outdoor system not to turn on? If the AC outdoor system is designed to operate with about 180 volts to 240 volts, 180 volts to 240 volts, is designed for 180 to 240 volts, and the voltage you have, the grid voltage you have on your environment, or depending on where you find yourself, the grid voltage you have there, if it is less than 180, the outdoor system will not turn on. If your grid voltage is less than 180, your outdoor system will not turn on. The indoor system can turn on, can stay on, but it will not be able, if it tries to transfer to the outdoor system through the transfer relay you have on your indoor, if it tries to transfer to the outdoor system, it will not turn on. I don't know if you get my point. It will not turn on. So you need an additive voltage, either through you need a voltage boost either through a stabilizer system, either through a stabilizer system, or you use a generator, or you try to change the source of your voltage input. Try to change the source of your voltage. From there, I believe you can get a reliable voltage source where you can work with instead of the low voltage. So that is it. I dey like. How many times you go just dey show one. Um Go what now you there? Now you fruit. This thing don't come from. Check that this thing first. You don't even see anything again at all. Anything.
That's all I can